One, two, one, two, one, two, one, two, one, two. Woo!
Hello, guys, and welcome back to this one. So today is going to be a very short one where we are going to be looking at the complexity of these mesh sorted files. And yeah, we are going to be talking about the waste first. Where do we see, it's brute force because it's brute force, but yeah, it tends to have waste. Yeah, it tends to have to be that there are places where we are doing stuff we're not supposed to be doing, and it is wasteful because now we are looking at, as we can see the waste is massive. We're calling a recursion for every head, while head every head find and every part. So basically, whenever we find the head, we still go to every single file to go and see, oh, where is, you know is there anything that compares to it. And that's where the waste is. The waste is the fact that we don't have anything that helps us, that helps us give us automatically the lowest value from those three files immediately in a streaming sense. Like, there's nothing that looks through the first three files of those three lists because it's already sorted. We should be able to just have something that will just check through those lists and then give us the um the lowest value, right, automatically, without us having to check through the whole list again. And yeah, that's equals to our next solution. But yeah, to just speak about the complexity, we have our time complexity to be n and k, because n being the amount of values in the list, and then k being the number of so you say, okay, n is not the list that we pass in, but every value in every list. K, image. Okay, sorry, I think that's trying to say imagine having 1k lists, right? So um that's basically just trying to say that, oh, we have a lot of lists. Imagine having like a lot of lists and then having thousands of values. So basically we are going to be visiting every value, but basically the k is the number of lists, right? So for every value we get to want to pop out, for every value we move to the sorted list, we have to, you know check every single list again. So that's why we have n times k, because we check every value and we check every list, and that is the only way we get our printout for that list, and that's very wasteful. So we see space, O of k, because obviously we're talking about the files that we have. So that's why we say O of k, because the many amount of file we have is going to be the amount of lists that is going to come into this guy, because our indexes lists will only create space for the list amount. So basically, yeah, we're talking about the files that are coming in, or the files that we are holding in memory or in the RAM, which is the indexes over here, right? We are thinking of this in a streaming sense, where all these files will be just be collecting, their head one after the other. This other guy will be held in memory. This is the only guy that will be held in memory, and it will be n of k, because it will be all the list that is trying to, so any amount of list that's coming, that's the amount of O's or zeros it would create in that first instance. So yeah, that's our space complexity, because indexes list will only create space for the list amount. So yeah, that's it for the complexity of this one. We could see the waste, we could see where we might need optimization, we could see the system basically for what it is. And yeah, subsequently going into the next solution, we are going to see how to mitigate that and how much we mitigate that. So see you on the next one. Muchas gracias. Bye.